Okay, now we're going to discuss how to communicate to the LB6770. The first thing you need to do with the LB6770 to communicate to it is to download the program, the PC application program, onto your computer via the internet and the Berthold website. So you will want to go to www.berthold.com and create you an account. This will enable you to download documents, download manuals, download software, download the application PC software so you can communicate. And first thing we'll do is, okay, you can see here that I've already created myself a name, username, and password and stuff. So now we will go to process control and we'll scroll down to density measurement, and we'll click on density measurement, and then we want to click on fracturing systems. After fracturing systems, we'll want to choose the LB6770, and then you'll scroll down a little bit and you'll be able to see three tabs about along the midways down the page. You'll see specifications, related products, and download. Click on the download tab. You'll see the different one: application report, brochure. We want to go to the software tool, and then you'll see the LB6770 PC application software. Choose this, and then you'll click on save, and then it'll show you that the download has been completed, and you can click on open, and then you can go ahead and open the folder, and you'll click on the setup.exe and it'll run through the complete setup for you. Okay, so now once you do that, you'll be able to choose the LB6770 PC application shortcut. You can also create you a shortcut to the LB6770 onto your desktop, which is fine. You can do that as well, and it just makes it a little bit easier. Then you don't have to click on that to go through it. Okay, once you choose that, it will show you the address for the device, and it will show you your baud rate. Click on connect, and I've already got an LB6770 connected here on my desks that I can talk to, and I've also put a check source there so I can get some count rate going. So you can see here that the PC application software has loaded and it's open and it's running. You can see I've got live counts per second, I've got test counts per second. Don't put anything in there. If you do, then if you don't re-zero it and click enter, it won't go back to your work mode with just your regular counts. You'll be working off test counts per second, and it'll throw everything off as far as your reading goes, unless you just are wanting to test the detector and see the different output, which I'll show you the current loop screen here too. These are basically the only two tabs that you need to open up, is the app fracturing and the current loop tab. The rest of it you really don't need. The current loop, the only reason you want to open it is to look at your output value. Do not change anything where it says calibration. If you start changing that, messing around with that, you're going to throw the 4 to 20 off, and then you're going to be calling Berthold to request an RMA to return the detector so it can be repaired. So we'll go back to the app fracturing screen, and there's three fields that you would like to, or that you should change, and one of them is the time constant. You can change your time constant. You can lower it to 1 second. The smaller the time constant, the more choppy the signal. The longer the time constant, like 10 seconds, the smoother the signal. And you must hit enter each time you change anything for it to save. So the only reason that you would really want a time constant down around a second is if you're buffering your time constant in your control van software or your blender software. If you're buffering there, then no problem, leave it at a second. But the smaller time constant, you also will be able to see, like if you're fracking and you go from sand back to water, you'll see a more rapid switch from the count rate to go up a lot quicker at a 1 second time constant. But most people are running right around an 8 second time constant, for example. A lot of the customers I've been to are running around 8 seconds. Then you'll see from the factory you will have 200,000 for a lower CPS value and 5,000 CPS for an upper CPS value. Now your lower CPS value actually stands for your 4 milliamps. Lower being 4 milliamps, upper being 20 milliamps. Okay? Now, typically what I suggest to do is to go to your lower CPS, and you'll look at your average CPS. Like if you've got this on a blender pipe, and it's a blender pipe, say 10 inches, you put the source on there, you got the detector mounted on, everything's mounted, you're looking at it. Say, excuse me, you get a count rate in your average CPS, you'll see probably 70,000 counts per second. This is just an example. You'll actually see what your average CPS is. So what I usually do though, if it was 70,000 CPS in the average CPS, I would put 72,000 in the lower CPS. Hit enter, and I would put the upper CPS value to 500 and then press enter. That way you're going to get a better resolution on your 4 to 20 milliamps. And the reason I say that is because if you left 200,000 counts per second in there and your average CPS was 70,000, then what you would see in the current loop, instead of 4 milliamps here, you would see upwards around 8-9 milliamps starting out with. So to me, the best thing to do, take your average CPS, add 2,000 counts per second, and put that value in the lower CPS. Now since this has only got 5,600 counts per second in the average, I'm going to just go ahead and put 5,800 counts per second in there. Hit enter. I'm going to put a value of 50 in the upper. Now if I go to the current loop, I should see close to a 4 milliamp output. Yep. 4.11. Okay, that's good. I'm going to have a really good resolution. Now I can close out my app fracturing PC application. I can close that out and go take my detector. I can connect directly into the control van or the blender software, and I'm up and running. Now all calibration will come from the blender software or the control van software. Now excuse me, David wanted me to talk to you a little bit about the TN or thermo sources that you may have. Those are sources that are around 200 millicuries, and the Berthold source is only 20 millicuries due to the fact of the sensitivity of the detector. So if you're going to still keep the thermo or the TN sources, I suggest that you use a bracket, a retrofit bracket from Berthold. That way you can add the steel plates that you're going to need to bring the activity level down to where it's actually usable. The sources, the TN sources and the thermo sources, you have to put 7 1/4-inch steel plates to bring the value of the source down to around 19-20 millicuries, just like the Berthold source. So that's the thing that you want to do. And once you do install the 7 steel plates with a berthold detector on the thermo source, once you do that, then you'll want to do the same thing. You'll come back into this software, you'll look at the average counts per second, you'll add 2,000 counts per second to that, put that value into the lower value, and I would leave the upper value probably at 500, but you'll put 2,000 counts per second added to the average CPS into the lower, and once you do that, you'll hit enter, and you should be good to go. You can close the PC application software back out, connect the detector up to your blender or your control van, and you're off and running. Now, Phil will probably show you maybe a still shot, a photo of the little blue box. Now, the way we have it wired here at Berthold is the RS485A is white, the RS485B is green, the 24 volts going to the detector is red, and the ground is blue. Now, what I want to stress to you mostly is look at the manual. The manual has the pinouts of the detector, and this is where you want to make sure your wiring connections are correct. Make sure you look at the manual for your wiring. One more time. Make sure you look at the manual for your wiring. If you put 24 volts to RS485, you will burn the detector up and you'll be sending it back, and it's non-repairable at that point, and that can be a costly mistake. So make sure you look at the manual for all wiring. At this point, I want to go ahead and I guess toss everything back to Phil and David. Phil, if anybody has any questions, please give me a call or whatever that I can help you guys out with while you're there, and look forward to hearing from you. For talking to y'all guys. Y'all have a good day, and let me know if you need anything. I've got an email address y'all David and Phil will have there, so if you need anything answered, just feel free to